I'm trying to so that, and I will like to have there is one request that I would like to have bi-directional conversation. So sometimes in between, if anybody can unmute and tell me yes, I am visible or anything, or I will like to be disturbed in between. That is what I want to tell you. That I would line what people are having this idea that switch on karo or band kar ke baith jao. So I will like to have some sounds from the from your side also. So I have planned my lectures like what is M and I, definition, difference, classifications of Monday units, standard. If you see the topics, these all are very elementary. Because nothing new. Don't expect from my side that I am going to deal with any very latest technology or some rocket science. The things are well known to you, or maybe it will be a reversing feature, because what happens actually with the students, or maybe with the teachers also, faculties also, that after some certain period of time, people feel shy to ask that, or they feel they are having some sort of hesitation that why I should ask what is now. Suppose what is there is one book, A.K. Sahani, that thick volume, a measurement and instrumentation, and everybody might have gone. And when anybody asks what is difference between measurement and instrumentation, people feel uncomfortable that time. So it happens, and that comes with this type of courses or with the discussion, the solution for this, because you will never find these things directly given as a heading or title, and you can find out in any book. So I have just compiled some of the things in such a manner, very informative by the end of this session. So this is how I have planned. Let us see some of the slides. I will just skip uh, because the things which has been directly copied from the book, that but idea or to make a good connectivity. Let's start with the what is Monday. If anybody asks that what is measurement and instrumentation, this is the very first question coming. Or define measurement. Define. First of all, because throughout our life we have come, I don't know how many things we have defined, and we have crammed those definitions. How to define the definition? What is definition of a definition? This is my first query. How to define definition? We are talking about so many definition. We were busy with since our school time, we are busy with this. So definition, what I come to this conclusion, which is a universally acceptable sentence or non-controversial sentence or paragraph, is known as a definition. A sentence acceptable everywhere. So that becomes this subject, measurement and instrumentation. So if anybody is saying that, suppose if you are claiming that my pen is 8 centimeter, the length of my pen is 8 centimeter. Now why you are, who has given you this authority to say that? Just think, who has given? Simple is, the answer of this is simply you will tell the person, because I have measured this with the help of a scale, that 15 centimeter or 1 foot, that 30 centimeter scale, and then I found that it is 8 centimeter, and that is why we. Now question is that then arise that where from that 8 centimeter has been decided. Then that answer will be that it has been calibrated against some big meter, 1 meter length, and then it has been from where that 1 meter length had been. Then this is a reiterative problem, means whether hen come first or egg came first, that type of situation. So simply measurement can be defined in one sentence. It's a process of comparison. Remember here measurement and instrumentation will. This course is electrical engineering course and we are dealing with a control system, but this M&I is not a copyright of electrical engineering. Remember, this is equally good and applicable for any branch of engineering. That's why mechanical engineering, the best book has been authored by the mechanical engineer, that E.O. Dublin book for this. So that is being authored by a mechanical engineer. So to all the engineering disciplines of engineering and sciences. So one way to define is, simplest way to define measurement is, it's a process of comparison. We are comparing and then we are reaching to that solution. What is the ultimate? Ultimate is the standard. Then I will be coming later on this one. Another way to define this measurement with respect to the electrical engineering, it is a cause and effect phenomena. Corresponding to that cause, there will be an effect. Effect will be in terms of the, suppose if it's a deflection instrument, so some deflection will be there. Cause may be, suppose if it's a meter, so current will be the cause, effect will be deflection. If it's a voltmeter, the voltage will be the cause, the deflection will be the effect. Simply wattmeter also, power will be the cause. So all. So there is a cause corresponding to the, if cause, effect means its output. So in terms of input output, see the things are entirely having different meaning with respect to this subject. Remember this, because we will see later on in this session itself. So the thing is cause and effect phenomena. This can be explained with this simple diagram, that either we are dealing with the, when we are dealing with the electrical engineering, so either we are dealing with the electrical variables or electrical quantities, we call it. A variable means electrical quantities or electrical parameters. Electrical variables means voltage, current, power, power factor, frequency, and so on. Electrical parameters means resistance. Resistive circuit will be either resistive, capacitive, or inductive, or combination of any of these two or all of these three. So that is what the input will be, and output will be effect, that will be in terms of the deflection. Here I am focusing on the analog. So another way to define this measurement is, it's a cause and effect phenomena. So this is, and that is how we can say this is a seesaw system. Right now, means single input, single output system. So then what is the difference between measurement and instrumentation? This is very important and interesting also. And I think how many of you have this, but there is a difference, and that is very minute. See, difference is measurement is quantitative. Quantitative means, and another is instrumentation is qualitative. Meaning of this is, what I mean to say here is that in measurement, when we are dealing with the measurement subject, or you can say measurement process, then there we are mainly interested in the quantity to be measured. How much is the value? If current is being, how much is the current? 2.5 ampere, 5 ampere, 4 ampere, 3 ampere. Means similarly the voltage or any quantity of parameter. We are interested in that particular value, quantity. Whereas when we are dealing with the instrumentation, we are also bothered about there also a sort of measurement is there, but quality of the measurement is also here has been achieved by a meter. You got the 5 mm. Now, when that is the measurement is over, instrumentation will come into the picture whether that 5 ampere is there because of suppose temperature change is there. So temperature change will change the resistance. If resistance change, it will change the current. So that is so that factor has to be taken care. Temperature change, pressure change, humidity, whatever the factors which can affect the current value. So that can be did. So there is a minute difference between these two. There also you are measuring something, here also we are measuring, but in instrumentation we are taking all the contributing factors together, and then finally the whatever the value is coming out, that is the instrumentation. Another way to distinguish the difference between these two is measurement is a system, whereas instrumentation is a scheme. Now, one scheme may include so many systems involved in that. Vice versa is not true. Vice versa is not true means a scheme, it is just like suppose in electrical engineering, let me have one example like we are in switch gear and protection, there is one subject happens to be in electrical engineering. So transformer protection scheme, generator protection scheme, motor. So there is a, so that is a scheme that involves so many system in that one. It will give you the protection against over voltage, under current, reverse power flow. There are, so individually they all are the system, but they all together gives you one scheme which becomes transformer protection scheme, like merge price protection and all. Similarly here also, as I told you, the suppose I will be taking one example, my current value, whether that current is affected by the temperature, pressure, humidity, wetness and all these things. So all those things will be taken care in case of the instrumentation. So this is the one difference. Now, as I told you in beginning that I will be talking about the, so classified from the application point of view, measurement can be classified as these three: monitoring of a process and operation, control of a process and operation, and experimental engineering analysis. Monitoring of a process and operation, I will try to explain. From application point of view, so first is monitoring of a process. Monitoring of a process can be explained like this, that suppose, is it visible? Please, I am knocking to the audience.
Yes, sir.
Things are going
yes,
smoothly.
Sir, going smoothly. A little bit delay is there, but okay, I think that's fine.
So in that I cannot help in that. Okay, so I will try to. Otherwise, things are visible.
Yes, sir. Perfectly all right.
So this is the monitoring of a process and operation. This is the first classification. See, in some of the applications, monitoring means in your house. What it measures energy, but what you are doing, you are monitoring the energy meter is doing what? It is monitoring the consumption of the power over a period of time. So how much energy? You cannot do anything with that one. Consumption is there, a meter is rotating, and if one person is coming after a month or 2 months or something, and then is taking the reading. So monitoring means just you are watching. See, there are so many terms. When I used to take the class, there I used to tell these type of things. Monitoring, there are resemblances or synonymous terminologies are observation, watching, monitor, TV monitor. We are monitoring TV monitor. We are computer. So one example I would like to explain here. Suppose if we are interested to take body temperature, the body temperature will be measured by a simple instrument that is known as thermometer. Okay, I will fit in this with this topic. What is being measured, monitored? It is the temperature, first block. Monitoring means what is being monitored? Temperature is being monitored. What is the process there? Process is human body. Human body is the process. And then operation is what? Metabolic changes or physiological changes in the human body. That is the operation. So that is how you can fit in. Similarly, the watt meter, gas meter, energy meter, film badges. Film badges is very important instrument. Don't know how many of you are knowing about this one, but it is a very good safety device developed by the biomedical instrumentation engineers. So that is actually being used for the monitoring of the hazardous radiations. The people, those who are working in the nuclear power plant or X-rays or something, so there they are being exposed, and they are exposed to the hazardous radiations. So that radiations are being monitored. So this is just like a pen drive sort of thing, and that is just fitted on the pocket of the employee. And what it is doing, that it keeps on counting the number of exposure. Everybody is having their own immunity. So based on the color will change after some certain. So suppose you need to be exposed not more than 500. So once it is crossing the limit, the color will change, and immediately the person will be transferred from that zone to the different safe zone. So this is how the film badges. So that is also a monitoring device which monitors this one. Now another is the control of the process and operation. So as you know that we are mostly talking about the closed loop system. Example, here I have taken the control action of the instrument, measuring instrument. Again, suppose the room temperature has to be maintained constant, or any process temperature has to be maintained constant. So again, we will use a temperature measuring device. Here we will be using thermostat. There in the previous we have used thermocouple. So measuring instrument will be thermostat. So here thermostat is acting like a control device, and there is a process. Suppose this is the process is there, so disturbances has to be, and there will be a set point. As the set point, let us say you have set it at 20 degrees centigrade. So just after 20 degrees centigrade, if it is going beyond that one, so the final control action element will take the action, and compressor will be on or something like this. So that is how it will be maintained constant. If it is switched off, so it can be switched on, so that temperature can be maintained. So here you see that same measuring device, temperature measuring device. Earlier it was thermometer. Here this is thermostat. But in that case, it was not doing any control. In the previous case, it was just monitoring. Here it becomes the control. So it is just like daily we are watching the TV. So there is a weather forecast. So we are getting the forecast like this weather. Suppose there is some forecast like coastal area will have some severe sort of tsunami or some. So for us, it's a monitoring process. Those who are not residing in the coastal area, that is a monitoring process. But the person, those who are residing in those areas, will immediately take some action, control action. They will go to the safe places and all the safety requirements, whatever is necessary, they will take. So that way, this process, the same thing may be kept in the category of monitoring, or there is no any hard and fast line like that this is it. So it depends how you are utilizing. Then the third, experimental engineering analysis. This is all about the simulation and experimental work, which we call it. So there are two types of the approach to solve any engineering problem: theoretical approach, it may be experimental. Now always there is a discussion that which should be preferred and why. So always the theoretical approach means simulation. Most of the time people nowadays students are doing all the simulation work most of the time. Experimental approach, now which advantage and disadvantage. Best problem solver is the person, those who are, if you could have developed the experimental model of this one and then you have gone for the simulation, it could have been a very good work. So this is what the meaning of the both are having their own advantages and disadvantages. Best is to consider both the things together. So this is how we some of the, there is no any other option like determination of yield point, friction factor, or speed torque character. So there you have to go for the experimental approach. Now switching over to the types of measurement or methods of measurement. Again, this is coming under the classification. So these are the have is given commonly. It's not available, but so there are two types of method. Method. Null type means AC/DC bridges. So I will not go in detail because you all are professors and you are dealing with the direct method, indirect method. These are the very local method of classifying the measurement or methods of measurement. So this direct method, direct, indirect, it's obvious using formula you are. So these things, I will just focus on those things which needs. Now this is one of the another in a very systematic manner, so it needs it. One thing, units are integral part of M&I. I don't know how many marks we have lost in our throughout our life from schooling days to the engineering studies and postgraduate and all, just by not writing the units. Everybody's life, this is the problem. Everybody, I am very much sure that we have lost some marks because it's up to the examiner mercy. If you are not writing, suppose 240, if it's a bolt, or maybe it may be watt, it may be ampere, it may be any, so it depends upon the means examiner whether he. So units are integral part of the M&I, and M&I is not the copyright of electrical engineering. Again and again. Now there are two types of the units. These things are well known to you. Fundamental units, they are 7 types. Everybody is knowing. Those 7 are, earlier we started our study with the MKS, CGS or FPS. There are 3 only. Then if you are electrical engineer, 4 will serve your purpose. MKSS system we call it. But total, to cover all the disciplines of the engineering or science, so we need to have 5 fundamentals, and those are length, mass, time, current, luminous intensity, temperature in degree Kelvin. Now this is just derived, means the things which can be derived from this one. So these are some dimensions of this. Now what is the importance of dimension? They serve 3 purposes. Number 1, in conversion from one system of unit to another, in deriving the equations from the physical quantity, and the third, in checking the accuracy of an equation. So this is how the dimensions are also important. Sometimes a wrong equations have been given to you, and by using this dimension you might have solved some numerical problem. So this is the importance of this. Now in electrical engineering there is one important link which I would like to discuss, because whenever we are dealing with any electrical machine or dealing with the power system or dealing with any device, electrical instrument or whatever, electrical engineering means whether you are dealing with the machine or power, some device, electrical device or some instrument. Normally we deal with the two circuits simultaneously, whether it is machine, device, whatever is possible. Always there are two systems simultaneously working, and they are electrostatic and electromagnetic. So there are two terms and there are two laws. Coulomb's law, which is defining the force between the two charges, F is equal to epsilon 0 epsilon r q1 q2 over dA square, and Ampere's law, that is m1 m2 and again divided by this one, but there instead of epsilon 0 which is permittivity, here it will be permeability. Permeability and permittivity. Permittivity is related to electrostatic. Permeability is related to electromagnet. So there is a very important finding that Einstein equation is there, and this is a very important link just to switch over from electric, because EMEC is one process, electromechanical energy conversion. So from electrostat to electromagnet or vice versa, motor generator action. So that is, we need to switch over from electrical to magnetic, electrostat to electromagnet or vice versa. So this is a very important link. This is giving you the dimension. This is multiplication of absolute permittivity and absolute permeability is 1 over c square, where c is the velocity of light and which will have dimension Lt minus 1. Lt minus 1 is the velocity, and this is the very important link, and that is how we are able to find out the different dimensions of. Now this is very important logo related to ISI certification mark. This is an Indian Standard Institute, that is Bureau of Indian Standard, BIS. This is effective since 1955, and it is made mandatory for 90 products from February 2013. The government has made it mandatory to have. So BIS, that is Bureau of Indian Standards, has its headquarters at New Delhi, and there are 5 regional office, and they are located at Kolkata, Chennai, Mumbai, Chandigarh and Delhi. So they are having the authority to give the certification. So always we are prefer to have this one. If you are going to buy a switch or socket or any electrical device equipment, so we will like to have or cable or wire or anything, ISI marker is very important. So this is another thing. Then one more thing I would like to introduce here, that is that those 7 fundamentals. So this is book has been written in SI system. SI means System International. Actually this is a French word. We call it as a System International, French. So international system of unit. So these two things are just, I want to rebrush the things because things are very tiny but very important from the knowledge point of view. Now standard, I would like to discuss something. Physical representation of unit is known as, of M&I is known as a standard. There are 4 types of the standards. Number 1 is international standard. We all must know international standards are being maintained at international level, and the agency or that organization is International Bureau of Weights and Measure. This is located at Sèvres, that is France. Capital of that is Paris. The place there is a place which is Sèvres. Formation is 20th May 1875. So this maintain what it gives you. It gives you the guarantee of highest possible attainable accuracy. I will be dealing this accuracy and all these things also. Then I will be little bit fast now because I have to cover a lot of things. Ensuring that all the latest technological development till date have been incorporated. This will give you the guarantee that all the latest technological development universally be universally acceptable. So calibrated against absolute instrument. Now absolute is above that one. So that they are very few in number. Now coming to the next primary standard.
Sir,
Being
there is problem.
they are,
Sir, excuse me, sir.
yes,
There is
yes.
problem. There is problem in your voice. There is some delay.
So
If you
what to
switch off
do?
your, if you switch off your video, then it's, I think, fine.
Let me try. Let me try. I have switched it off now.
Yes, sir. No, it's fine, sir.
Let us have it make sense. Okay, and let me share it again.
Sir, PPT is visible.
No, I have stopped that.
Okay.
Is it visible now?
Yes, sir.
Is
It is visible. Yes, sir. It is visible, sir.
Yes, sir, it is visible.
Is there any improvement in the lag peak time?
Yes, sir. Voice is now.
Now it's
something clear.
okay.
Yeah, it's okay, sir.
In this, what we can do, Shekhar? This is the, I think, not at all my fault.
Network issue, sir.
Networks. So it's okay. So should I continue with this?
Just, sir, press F5.
That I will be doing.
Okay, sir.
So this I was discussing about international standard. Then there is another standard, primary standard, which we call it as a national standard, but name is fixed, primary standard. Every country has to maintain the standards. In India, the headquarter is, I think most of you may be knowing, and I have visited this place so many times, National Physiological Laboratory, NPL, New Delhi, Pusa Road. I'm telling you the address also, you can go and see the things, and there you will have a different. Then there are some atomic standards, like frequency standards. So that is being maintained in India by BARC, Trombay, Bombay. Formation of this NPL, about NPL, this is January 4th, 1947. And these instruments or these things national. Then secondary standard, they are maintained at regional level like BHEL, NTPC, IL quota is one very good industry. So DRDO, and so these are just to easy accessible. So these are regularly calibrated against the primary. So there is a hierarchy, you can say. Working standards are being maintained at local level by all IITs and ITs. They are coming, and we are providing the consultancy or testing services. So that is basically the we are maintaining a sort of standard, and their instruments are being calibrated against our and that is working standard. So this is a hierarchy. Hierarchy means these needs to be, the instruments need to be calibrated at some certain interval, so that there should not be any problem. So because so far I am talking most of the time about the analog, but IEEE standards, they deal with the digital interface and programmable instruments. So this is highlight feature of this slide is there are 4 standards, where they are being maintained, that must be known to you, and there is a hierarchy, and each one of this must be calibrated against the other one. They also are known as echelon labs. So these information must be there. Now, functional element of the M&I, this I will just go through. There are 5 elements. Any measurement system will have this. So there is a measurand. Measurand means quantity to be measured. Then there are 5 elements: primary sensing, variable conversion, variable manipulation, variable transmission, and data presentation. And last is the observer. Now here I would like to tell you that it is not always necessary that all instruments should have all these 5. Number 1 and last one has to be there. Means primary sensing element, the element which is coming in physical contact with the first time with the measurand, that is known as primary sense. So that has to be there, and then data presentation has to be there. Rest, variable conversion, variable manipulation, and variable transmission, that depends upon the way you are utilizing the instrument. But this is general or functional element in which 5 elements are required. So this, I think most of you may be knowing. This is one example which I will be giving here, just to know that this is a simple example of this instrument is known as pressure gauge. So pressure gauge, in this is a very compact instrument. So if we are interested to measure the pressure, so what we will be doing, that we will be dip this instrument. This is just like a size wise, just like a bulb, 100-watt bulb or 60-watt, that is. So that will be dipped inside the reservoir whose pressure has to be measured. So that pressure will be exerted on the piston, then piston will move. The pressure will be converted into the force, because the pressure has been applied on a certain area. So that pressure will be converted into the force. Because of that force, we transfer through the piston rod, and then again it will compress the spring. So there will be a conversion here because of the piston rod. Then piston rod will be data transmission. Then it will compress the spring. You know the spring action. If it will compress the spring, it will decompress also. So it will be decompressed. That means linear moment in this, that will appear on a broader level. It will be magnified, and it will appear in a wider sense over a scale and pointer which has been calibrated in terms of the pressure. So this is the example how to fit in this those elements in this. So as I told you that first and last will be there, primary sensing element. But you see the piston here, measurand means quantity to be measured. What was the quantity in this case? Quantity was the pressure. So pressure will be the measure. First element which is coming in touch of that. So primary sensing element will change it will sense, and then it will change the conversion of the element, means pressure has been converted into F, that is force. Then conversion will take, linear motion will be there because of the thrust of that spring, and then linkage will give you the manipulation. It's some sort of a gear arrangement, and then there will be data presentation. Data presentation will be either a scale pointer, or it will be digital display, it will be a recorder, it may be a transmitter, it may be anything. So this is now generalized input output configuration. Here I would like to tell you that generally, I told you that it is a cause and effect means seesaw system, but in real practice, seesaw system. There are three types of the input. One is interfering input, modifying input, desired input. And because of these three types of input, there will be a single output. So the actual system is not seesaw, it is MISO, multi-input single output system. So this is what I wanted to introduce here. There are three types of the unit inputs. They are namely desired input. Desired input means those input for which the instruments are made intentionally sensitive. We have deliberately made our instrument to be sensitive for desired input. That is desire, our desire. Intentionally we have designed. Now, interfering input, those input for which the instrument are unintentionally sensitive. Like in the beginning, I have given you one example. Actual current is 5 ampere, but because of the temperature change, it is maybe giving less than 5. That is giving you a interfering input, and because of that, my instrument is unintentionally sensitive. We don't our instrument to be sensitive for, but unfortunately it is sensitive input. Then the last is modifying input, those input which can be modified, the cause and effect relationship. Means there is a equation coming out finally. So it may cause a change in the desired input and or interfering input and slash or means it may cause change the desired input or it may change interfering input or maybe both. What is the final effect of this? It will modify the equation itself, which we generally don't consider. So there is a situation like this. So that is what I told you, that is the meso system which we are dealing most of the time. And these are the mathematical operations which has been denoted there, FD. Here I would like to just find it within 3 sentences that the FD means it may be a constant number that gives the proportionality constant relating constant input and corresponding static output, linear instrument. Like suppose if you are dealing with a amplifier, so amplifier is having some gain, 100 is a gain, suppose 1000 gain is so if you have applied 5 millivolt, it will give you the 5 volt. That is quite handy. So it's a linear, means just a constant is sufficient for that to deal with. For non-linear instrument, it is not possible that always we are having, so a constant will not be adequate. It requires a mathematical function, maybe a function, maybe a quadratic equation or something like that will be required to just relate this input output. Or if dynamic input and outputs are there, so maybe the mathematical function or a constant it may not be sufficient. You may require to deal with the differential equation. So that is what we are doing in the control system also and in the instrumentation also. So these things I don't want to give. I would like to just give you one example of this thing. Suppose in this very example, if you see it carefully, there is a instrument which is known as electric resistance strain gauge. Electric resistance strain gauge setup. So here the purpose is we are interested to measure the strain applied to that test specimen. So suppose a force is applied. So there is a strain gauge which is pasted on that test specimen. Normally strain gauges are very delicate helical, so that is being pasted. And that is working just like a one arm of a Wheatstone bridge. You know, everybody is knowing Wheatstone bridge. It's a DC bridge. And then there is the measurement is being carried out in a 60 Hz AC field atmosphere. So in this, the process is like that when no force has been applied, so no change in the RG, no strain will be there. So there should not be any output. E0 should be 0. But as soon as we apply the force, tension, so there will be a strain change in the RG, there will be a strain, and there will be some output voltage corresponding to the value of the force applied to that one. So the value of voltage will give you directly the idea of force applied, because it is directly proportional to the strain gauge. The formula which is coming out to give this voltage is E0 is given by GF, means gauge factor, RG, epsilon is the strain, which EB is the battery which is connected in that, which is shown in RA, that is the resistance of Rg plus Ra square. This is the equation. Now here the question is, what is the desired input? Of course, strain is a desired input. We want that instrument should be sensitive to strain only. This is desired. We want this. But interfering input, because 50 Hz AC field is there, so because there will be a electrostatic field. So even then, no force. What, from where that voltage is? It may be it is present over there. So in actual case, we don't have any strain, but it is getting. So interfering input will some disturbance. Shekhar.
Yes, sir. I am muted, sir.
No, somebody is. Is it better than the previous one after switching of the video?
Yes, sir. It's very fine, sir.
Achha. Then the last one is modifying input. Can I interact with any one of the participant also?
Sure, sir. Participant, please unmute. Participant, please unmute yourself.
Just have a hello to me, so that I think that
Okay.
somebody.
Actually,
Sir,
one of the faculty, one of the faculty from REC Sonbhadra has already said hello to you. Dr. Vijay Pratap Singh. Dr. Vijay, you are there? Anyone
can check anybody, any other?
Okay. Anyone can
Hello, sir. This is Roshan from United College, Allahabad.
Yeah. Good name, please.
Roshan Chitranshi from United College, Allahabad.
UCR.
UCEM. It is basically.
010.
It is 342. 0 is the parent.
Another. Yes. Right. Okay. Welcome. Anybody else?
Sir, KP Singh sir is also.
This is Shubham from.
Yes, please. KP Singh sir is there.
Yes, sir.
It's so nice. KP Singh sir is there. I just recalled him in memory when I was dealing with the and or with oblique with the slash sign. So,
okay. Khavate char.
Yes. Anybody from SVNIT? Anybody from SVNIT?
I think from SVNIT. Any participant from SVNIT?
Participant or maybe faculty or anybody? I would like to. When anybody is online, please let me know.
Okay, sure, sir. Sure, sir.
I would like to, because it's my alma mater also. So,
okay, sure, sir.
Okay, so going ahead with the same thing. So as we know that there are 3, 2 we don't want, 1 we want. 1 means desired we want, interfering and modify we don't want. So naturally we should have methods. Those methods has been named as methods of inherent insensitivity, method of high gain feedback, methods of calculated output correction, methods of signal filtering, method of. In all these methods, different techniques are being involved. I have some slides, but I will just. So it will be not very good for my point of view as well as from you. So these are inherent insensitivity means we are. This is based on the sound design philosophy. High gain feedback, that is another philosophy. In all this, the effect of the idea is just to how to minimize the effect of modifying input and interfering input. So some filtering process. Filtering can be done at the input side, output side, opposing input. Sometimes we are deliberately introducing the interfering input in opposite direction so that it can cancel out the effect of. So there are different methods and they are being applied. So sound the basis of this one, then high gain feedback factor, it can be proved mathematically. Second figure, we have the same system with the open loop. So the effect can be minimized. Similarly, calculated correction. So this is also it requires knowledge about the. We should know how the quantity is going to be input side. So you can apply the filter. Filter means noise, unnecessary thing can be filtered out. Then filter can do this output. It is based on the multiplexing, demultiplexing principle. Opposing input, as I told you, intentionally it has been introduced and it can be cancelled out. Here we must have so idea. Now this is what I am interested to tell you. The next one. That's why I just switched over very quickly to this one. That there are three types of characteristics: static performance, dynamic performance, environmental. And I will focus and I will try to give some deliberation on this one, and I will request everybody, because everybody is dealing with this subject while they are teaching. So static performance, dynamic performance, and this all will be dealt. Static performance is being studied when the input is constant or not varying, or with respect to time, or at some value. Static performance is being studied when input is constant, not varying with respect to time, or at some constant or not varying with it. So at that very time, whatever the things we are going to study will be coming under the category. And the very first thing is range. Range, the things, there are four types of the range. All the instruments must be arranged, grouped in this four category: unidirectional, bidirectional, asymmetrical bidirectional, zero suppressed, or expanded scale. The figure will make it very clear. The first one, unidirectional, very obvious. Bidirectional, that is zero centered. Asymmetrical, that is zero is not symmetrically placed. You just see minus 20 to 80, and then zero suppressed, it is starting from 20. So this is the range. All these span means upper bond minus lower bond, that is a span. Upper bond means full scale deflection, minus lower bond will be the span. If you just compare these previous example here, so what will the span of these 1, 2, 3, 4 figure 1, 2, 3, 4? in all case it is 100 except 4. I think you can verify it. In all these cases it is 100 except last one, 100 minus 20, it will be 80. So that is what has been delivered here, that all 1, 2, 3 are having same inputs. I will not take much of the time in this because inputs can be of 3 types, which has been already discussed. An actual system is ISO system, but actually it is a multi-input single output time variant system. This measurement outputs, it may be of 3 types: analog, continuously varying, discrete, not continuously varying. Coded means it may be impedances. Load impedance. Input impedance should be very high as possible. Output should be very low. Why? When we are going through these terms, we must be able to understand and should able to convey our student. Because there is a effect which we call it as a loading effect. Instrument should not act as a load in the circuit in which it has been connected. So always remember, the any using should not act as a load in which it has been, because from where it will take the power. So if you are maintaining these two, means input impedance is very high and output impedance is 0 or as low as possible, then there, and that is what we call it is a proper impedance matching. So impedance can be of 3. Don't take these impedance with respect to the impedance Z is equal to under root R square plus X square. That is not the meaning. Things are entirely having different harmonic content. In this subject, these all are we are dealing with the static performance characteristic. In the perfectly designed instrument, the information must be there with the fundamental. The rest all can be with the higher. Means there are harmonics in the system. So fundamental should contain 80% in the perfectly designed instrument. Hysteresis, immediately when this word is coming in our mind, immediately the figure of BH curve is coming in. Here we are nothing to do with the BH curve. Here so if suppose ammeter I will take, it's 0 to 5 ampere range. So if you increase the current like 0, 1, 2, 3, 4, 5, 5 is the FSD. Now you just bring it down. 5, 4, 3, 2, 1, 0. So what is expected that the path should be repeated, but in actual practice the path will never be repeated. And there is a small portion where the path will be repeated, then it start deviating from that path. So forward path and reverse path is not same. Action is same, but it is not. Why it is not there? Because it's due to the thermodynamics. The second law of thermodynamics, 100% reversible system is not possible. This is given just is very resembling with the BH curve. That's why maybe this name is given, but it is nothing to do with the BH curve of that. So please don't confuse yourself as well as others also. Dead zone, it is very common to the for a small change in input, the dotted line zone. For a small change in input, there is no change in output. That zone is known as dead zone. There are some certain periods where there is no change in the output. That zone is dead zone. True value means a standard value. In lab atmosphere, it is obtained differently, means we are taking average of infinite sets of the reading, then another set of the reading, another set of the reading, and then we are taking the averages of average, and then finally we are coming with the value. Otherwise, it's standard. Whatever is available to you, just deal with that one. That is what the true value. Accuracy, closeness with the true value. Precision, reproducibility, degree of reproducibility. Difference between this. I would like to have discussion here. Accuracy, precision. the things are very, see, it is not always necessary that the instrument which is accurate may be precise also, or vice versa. It is not giving you the guarantee the instrument which is precise will be accurate also. All are different. This example I normally used to give in my classes because it is very easy and permanently be there with there. Suppose if you are having 3 instruments, instead of having instrument, we have 3 students. They are maintaining this routine of 1 week routine of the Monday, Tuesday, Wednesday up to Thursday, Saturday. Student A, instrument B, A, B, C are the not the instrument, it is student. Now if I ask which one is more accurate, which one is more precise, and what is about it, please participate in this discussion. I would feel happy that something is. Please, anybody, please. I can't hear anybody.
C was more accurate and B was precise.
B.
Student C is more accurate.
Which one is more accurate?
Student C.
Accurate.
I think, sir, the first one is more accurate as compared to the second one.
That means there is a topic which need to be addressed. See what has been, I have already defined that accuracy means closeness with the true value. True value is 930.
Yes.
C is no more accurate.
Degree of reproducibility, how many times the same reading has been reproduced. So my answer here is, and we will have a discussion if you wish to have. A is accurate, simple. A is accurate, B is precise. What about C? C is accurate as well as precise. When the matter comes to the selection, because we cannot compromise with one at the cost of other. We want preciseness also, we want accuracy also. So when the matter comes to the selection, we will certainly go for the C. But when the matters comes to the distinguishing the difference between these two, A is accurate because you see true value is 930. 930 has been repeated 3 times. And 929 and 931 are the same thing. Same 929 पहले आ रहा है तो अच्छी बात नहीं है. That so 3 times. Here the B is consistently maintaining his inconsistency of coming late 950, 50, 50, 50. One day by chance it is 931 and then this. And C you see 930 2 times daily 929. So this is accurate as well as precise. C. Preference wise, when matter comes to the selection, we will certainly. So this is how you should. Error measured minus true. It is normally represented in terms of the percentage. Correction is just opposite to this one. I will not give those importance of these things. Sensitivity. This is another very important. Sensitivity is now two things we can distinguish. If the one instrument of same make and model, suppose a meter of 0 to 5 ampere range of same make and model is available to you, and it has been asked which one is more sensitive, accurate, precise. Now I think by this time you can able to distinguish the difference. Now I am asking you, out of those A and B instrument 0 to 5 ampere same make and model, which one is more sensitive? It is not at all related to this one, accuracy and precision. It is entirely different. So it is being defined as change in output divided by change in is defined as static sensitivity. So just to be emphasis on this one, the best one is the instrument which is dealing with the, suppose I have two instruments 0 to 5 ampere ammeter to ampere current, and B is taking 60 to show the 60-degree deflection 2.3 ampere current. So which one is more sensitive? Which one is more sensitive? One is taking 2.5 ampere to show 60 degree. Another is taking 2.3 ampere to show 60 degree.
Is more
Three.
sensitive.
Sir, B is more sensitive.
B is more sensitive. Yes.
Input mathematically also, if the denominator input, if it is less, the sensitivity will be more. So it is output over input. So far in our life, we are knowing only this as a efficiency. Output over input is efficiency, state way. So my dear friends, please remember these things, that this should not continue further. In terms of this subject, the things are happening. Here the sensitivity is also, efficiency is also having unit. So far we are knowing that efficiency doesn't have units, because it's output over input, what over what, it's a no, I will just show you. So here I think it must be clear to you. Drift is a zero drift, and then sensitivity. This graph is showing you zero drift. This graph is showing you the sensitivity, because A and B are having different slope, output over input, different slope, sensitivity just previous slide. So A and B of sensitivity in second figure. Here both A and B are having same sensitivity. Slope is same. Change in input over change in output over change in input. Both, but only difference is zero is shifted. Now this is the third, which is showing you the both zero drift as well as sensitivity drift. Resolution, it is the minimum or smallest quantity which can be measured with the certainty, that is the least count instrument which can have. So this is also very important. Then uncertainty is there, because always if you are having a least count, so the instrument will have its limitation, that plus minus 0.1 volt, in between reading it cannot be. So there is a formula for this one which has been designed. Overall uncertainty is being propagated in the compound quantity. So this is very, very important. My dear friend, one more thing. When we think this or industry or even the, so this subject has of no use. But this sensitivity, preciseness, accuracy, errors, whatever we are talking about, or uncertainty and all this, don't consider. They becomes very, very relevant when you are like uncertainty propagated in the compound quantity. I am just giving you an example. When you are dealing with the space technology, aircraft technology, or all other technology, different sessions, we are dealing with those things also. So of course I am also doing the work in the same area, but I am dealing today with the fundamentals. So don't take these things with respect to the lab or industry, because in the lab, whether current value is 2.5 or 2.3 or 2.6, what, it is not going to affect. But when, because these, suppose you might have seen this type of situation, the rocket has to be launched, or space technology, the satellite has to be launched tomorrow, and then suddenly there is a headlines that satellite failed to launch. Why? They all are big scientists. What happened? Because out of those thousands of the parameters, there may be impact of one is sufficient to just make the system, whole system failure, the scheme failure. So that is how, because it is propagated. So plus minus one here and there. So one formula has been given. So we cannot. So there it has all. Then this is also very important, readability. These all are, we are dealing with the, with respect to the this with respect to static performance characteristic, thickness of the scale marking, thickness of the pointer, clarity of the scale marking, alertness, sensitivity, of a person. So all these will play, because see this, but what makes the thing branded and low, sorry, iPhone, where everything, the neatness, the cleanliness, clarity of the scale, marking, written thing, and if everything you see it will be blur type or something. So that is what local made, Delhi made. Yeah, this is the, so this is what that. So this is. Uh, please, Odeshji, I can continue for, because I started late.
Yes,
10,
sir.
15
Yes, sir.
minutes.
Of course, you may continue for.
Uh,
Yes.
okay. Please let me know 5 minutes.
No, sir. Up to 5:30, I hope you can continue. No problem.
Okay.
Okay.
Uh, this is the very important term which I would like to tell, because normally I have not seen in my life this in any book about this one, efficiency. So far we are able to distinguish the difference between the which one is more accurate, which one is more precise, which one is more sensitive. Now, out of those two instruments A and B, I am asking which one is more efficient, because if anything is having one quality like it is having accurate, it is doesn't give you the guarantee of being precise or being sensitive. Similarly, being efficient. All four, five, all the terms are individual, independent. All the terms are independent. It is not related at all that one is giving the guarantee of another. It's not like this. Now, efficiency, just see and think. And here I told you that efficiency, because normally so far in our life we know efficiency everywhere in mechanical engineering, electrical engineering, motor, generator, power system, everywhere. What is efficiency? Output over input, output over input, output. But here output over input is already has been defined as a sensitivity. Sensitivity. Lower will be the input, higher will be the sensitivity. Now here, I think you will. This is suffix always. It is not normal efficiency. Normal efficiency is output over input over. Instrument efficiency is different. So instrument efficiency will be defined as FSD divided by power required for FSD. What does it mean? The physical significance of this. See, in engineering study, what is my view, that the things which we are having, the physical concept of that will be rather easier than physical significance. FSD means full scale difference. Suppose again I will be taking the throughout my discussion, I am taking are there, emitters are there of same company, same make, model, brand, everything same, everything is same. Now I have to given this job that now I have so far I am able to distinguish the difference between which one is more accurate, precise, sensitive. Now I am asking which one is out of those two will be more efficient. Very simple, 0 to 5 ampere. 5 ampere is the FSD. Suppose one to move the pointer from 0 to some certain value. Suppose FSD means 5 ampere. Pointer will move from 0 to for its own operation. to bring the pointer from 0 to some certain value, let us say 5. So though this power drawn should be as minimum as possible. Ideally, it should not be there. There are two measurement and instrumentation rule. One is it should not alter the circuit condition, and second is that power drawn by the instrument should be as minimum as possible. This is these two are required, but power required must be minimum. It cannot be made 0 because certainly it required some power. So suppose one instrument out of those two 5 amperes meters, one is taking 0.2 watt to show the FSD, that is 5 ampere. Another is taking 0.21 watt to show the FSD. Now I think your answer will be very clear. The meter which is taking less power to show the same FSD, that is 5 ampere, will be more efficient than the meter which is taking more power. So this is how we are defining the instrument efficiency. And here, if you are dealing with this instrument efficiency, have a unit. Like suppose if you are having a meter, so ampere per watt. Voltmeter, it will be volt per watt. Per watt meter, suppose it's analog watt meter, so it will be watt over watt, may not be there. But this should be. So I think you must be. Now dynamic performance characteristic, because control system and this suits much of this one so far. So I have covered around 20 topics related to the term 20 somewhat like this terminology related to the static performance characteristic, and this must be understood in the same manner. The problem is not that must be the fundamental within yourself also. Dynamic performance characteristic. So I will just go through this quickly because people are very expert in this, and they are. So there are two types of the analysis in the control system. Instrumentation, both are very much related to this one. So frequency domain analysis, time domains. In frequency domain analysis, I will just show you this. There is a measure and usable output, RS, CS, cause and effect, same thing. So in this case, in static performance characteristic, it is being studied when the input is not varying with the time or constant or known value. Here dynamic performance characteristic. Frequency domain analysis, features of this is transfer function, which is output over input. Transfer function means sensitivity. If it's a linear system, it is sensitivity. So if you are knowing the things, know with the authority, so that you can dictate the terms. So transfer function of the given example, Fs is Cs over Rs. So if S is being replaced by J omega, that becomes the polar representation, and rectangular representation is possible. Then there are A and B. A is the real part, B is the imaginary part. These all are very basic terms. Amplitude versus frequency, phase angle versus frequency. This is Bode plot. Then we are dealing with another analysis which we call it a polar plot, that is Nyquist plot. So I will just sinusoidal. Laplace transfer function means time domain analysis. Operational transfer function. Laplace means you can switch over from time domain to frequency domain and vice versa, because inverse Laplace is able. So most commonly we are using Laplace because there is a flexibility that you can switch over from time domain to frequency domain or frequency domain to time domain. Sinusoidal, that means frequency domain analysis. So if this is the situation, mathematical general dynamic differential equation for the study of dynamic behavior of the transducer. So if we are having nth order, So we can write the nth order differential equation. This is the differential equation. I think nothing new is there. If we replace d by dt with the operator d, so the same equation divided by an and this one. So an and all these are related to the other input and output a and b. Then it can be written as I told you initially also that 80% information must be there, higher order may be neglected. If the first and higher order of the derivative in inputs are not available, so b coefficients can be made 0. So b over an dn can be written like this one. So if we can say please check there is some disturbance, some knowledge. No.
Yes, sir. Any issue, sir?
Your audio is breaking.
Professor Giri, sir? I think we should wait for a minute. I think there are some network issues with the sir. So he'll be trying to join. So we should wait for a minute. The session will be concluded within 10 minutes.
Am I audible already now?
Yes, sir. Yes, sir. Now you are
There was
audible.
some disturbance in between.
Okay, sir. Now it is okay.
It's okay. So I will
It's
switch
okay.
off my video and again share the screen. Please give me
Yes.
10 to 15 minutes
Yes, sir. Yes, sir.
so that I can bind it up. I'm little bit fast. So please.
Okay, sir. That's fine.
Okay.
Yes, sir. Your PPT is visible now.
Mathematical relationship, because I know my faculties are very much expert in dealing with this differential equation and deriving these transform. My concern here is what I wanted to deliver here is that there are three types. One is operation is being preferred because we can switch over from one to another, and then there are some other terminology that I will just name it because you people are not the UG or PG students, so you all are knowing what is right time, peak time, settling time. So these are the definitions. So this I will just go through this one because I have been given a limited time, so I don't want to torture you. So these all are the definition related to those terms. Environmental performance. So far we have covered two performance characteristics. One is static performance and frequency, and that is dynamic performance characteristic. Environmental performance characteristic, under the environmental performance characteristic, the following things are being considered. These are what is the storage, seeping, leakage, and moisture effect. This is also very commonly taught to the UG/PG students. But my dear friends, I would like to request and like to you all that please pay attention. Errors for the electrical engineering student in this way, because in the books there are problem with the books. Even the standard books like Sani and all these, the most common, nothing wrong. Individual topics I personally refer different books, and this lecture is just the collection of the best. So please try it. Error is of three types, and it is names has been given another name, or is given. Systematic is also known as cumulative error. In some of the book it may be given. Accidental, it is given as a random error, compensatory type of error, or chance error. All can be named possibly. Miscellaneous type of gross error. Gross
Sir, you are not audible. Participants, just bear with us. Just be patient for 5 more minutes. I think due to the network issues, he is leaving from the meeting.
Am I audible now?
Yes, sir. Yes, sir.
In between,
Yes.
something is happening.
Yes, sir. I hope there are network issues. Due to that, it is
Okay.
being
Okay,
disconnected.
let me very quickly finish it off.
Okay, sir. Okay, sir.
Is it okay?
Yes,
Screen,
sir. Visible.
screen.
Yes, sir. PPT visible.
Okay. So error analysis, I was just so these of three types. Now these three types are having, one is having fixed magnitude and sign, another is having random, neither magnitude fixed nor sign. and third one is gross, which is having combination of 1 and 2, both. For sometimes it is systematic, for sometimes it may be behaving in the random manner. So that combination of 1 and 2 will become the third type, that is gross. Now let me explain these. Systematic is of three types: systematic or cumulative. Which is systematic means which is magnitude. Now it is of three types: instrument error, environmental error, and loading error. In all these cases it is having same fixed, same sign. So they are cumulative. Cumulative means it keeps on adding, because sign and magnitude are fixed, so that keeps on adding. So it is better from the measurement point of view, because you know what is happening. So finally, whatever the reading is there, you will deduct that much and you will get the actual one. So these instrument error, environmental error, and loading error, they are the part of the systematic error. Another accidental or random, where the neither magnitude is fixed nor the mag. So they are coming because of these three regions. These regions may be audible. Let me know.
Yes, sir.
Yes, sir.
Audible.
Yes, sir. Audible.
Okay, okay. So this is of three types: inconsistency associated with the accurate measurement of a small quantity. Then the presence of system defect, and the third one is effect of random. I will try to explain you in the first one. Then you will realize the actual problem. Accidental means neither the magnitude is fixed nor the sign is fixed. Actually, what happens? Suppose if you are an engineer, and if any UG/PG student has got a job, a very good package, and his job is as an instrumentation engineer or electrical engineer, he has to measure a sample of 4 millimeter length, and he will check it. The length, if it is 4 millimeter, it will be tested, okay, pass. Tested, okay, pass. This is the job, and he is getting very good package of 50 lakhs per annum or something. So he will be a happy person. But what will happen to him? He will go to the office and he will take first sample 10 a.m. morning fresh, 4 mm tested, okay, pass. Then take another, take another. So up to 10:30 he will be measuring it. After 10:30 what will happen? If it's 5 mm, it is tested, okay, pass. If it is 3 mm, tested, okay, pass. After 11 or by the in afternoon, he will become misfed up doing this job, because measurement of a small quantity. So are you agree with this fact? So sometimes what will happen, the person, and if he will be given the same job for doing throughout the year, so after within 1 month or 2 months, he will become mad if that same kind of job has to be done by that one. Whatever, he will not bother about the package and he will leave the job, run away from that place. So that is what the nature of this job is, because it is inconsistency which has to be associated with the a small accurate measurement of a small quantity, because quantity is small, that's why this problem is there. Now question is there, who is doing this one? Because these things are being done, so computers are being preferred.
Sir, again, voice is breaking.
I think again the same issue has been happened. Wait for a minute. Again, I think network issue.
In between, I am getting some disturbance.
Yes, sir.
What to do?
Just conclude, sir, your session. It's fine, sir.
This is what. Is it visible?
Yes, sir. It is visible, sir.
Histogram?
Yes, sir.
Okay, I will just go through some of the steps. So these things are well known to everybody. So these normally we are going for the average, then standard deviation, so then variance. So nothing much to median. I would like to just tell 1-2 lines for this one. Median is very important because what happened when the multi samples are being taken. Normally in the lab we are taking take the 5 readings and take the average of that. That will be the best reading. This is what normally done. But if the readings are being collected from the different places, so because of the mistake of one center, the average will be deviated very and will shoot out and it will be all together a absurd value. Are you getting? Suppose the data has to be collected from 5 countries. Suppose Singapore, Delhi, Chennai, or some New York or something. So 4, 5, 6 stations are there. Suppose one has abruptly given means unexpected reading. So that time average will not be the good solution. That time we are going for the median. So median, in this we are arranging the things in a ascending order and then the middle one. So odd man will be automatically out, odd reading. If number of the odds are, if numbers of samples are odd, then take the middle one. If it is even, then take the average of those two middle one. So this is median is a very important solution for this one. Now I will not go through this one. And I would like to conclude with one of the very important aspects which people normally don't give the importance of this one. And I would like to tell you because in course you will be most of the colleges and new colleges they are using most of the time digital be preferred simply, and it is not being preferred whenever the sophisticated application like the aircraft technology, space technology, missile technology. If you see, I think you might have seen the this one clock cockpit of the aircraft. You might have seen. So there you see all those meters are there. They all are basically the analog instrument. Digital display. Digital display is very popular nowadays only because of one reason that it is very, you can say, cheap, and another thing is readability is very good. So अगर कोई चीज सस्ती है then and it's easily available in the low cost, then it will be popular. Otherwise, as far as the accuracy, precision, sensitivity and all those terms are there, there is no match still in this present day technology of those digital instruments, especially the PMMC. So there one important instrument part is that is spring. Spring is designed in such a way 60% of the cost of the instrument. See 1 meter. A meter normally it's cost in the lab analog meter it is costing 1000. So 600 will be the cost of the spring only. And the same range meter is available in the NPL and that is costing around more than 10 lakhs. Same range, same thing. That is also measuring 0 to 5 ampere meter is there. So what makes the difference? It is the material and selections. So spring design is one important aspect, it in a properly designed spring, length versus thickness ratio must be maintained 3000, and length versus width, it should be 30:1. But if you are going to maintain, the cost will be further going to be high. So to make it economical, we are going for the smaller value, 10:1 or 1,000. Material property, these are the material property. These are the materials name property of the phosphor branch is most economical. Otherwise, you should go for the platinum, silver, platinum, iridium. These all are very costly. So now this will be my last slides. So pivot and jewel, this is also we are not taking much of the care, but if anything is mounted and continuously wiring, so there is a Hertz equation which is coming into the picture. So always the hardness of the material used for the jewel. See, in the technology, it is always there that all the latest development or comfort level is possible because of the sensor, transducers, and that is possible because of the material science development. So if you see this complicated Hertz equation, so that says you that hardness is normally measured in the Mohe scale. So pivot should have 6 and jewel should have 9. So the material used for the pivot is stub steel, silver steel, and hardness of jewel should be more than this one. So hardest material is diamond. So diamond jewel should be used. Blue. Now, if you are using diamond as a jewel for the lab instrument, so it is not. So that's why. But there, where you cannot compromise with anything, there we are using diamond. That's why that is costing 10 lakh. Then normally we are using other material like blue sapphire, red stone, and this one. So I have taken sufficient time, I think, and this is my and